As you can see, this is application performance monitoring is the new unit testing. My name is Nathan Acuff. I'm a partner at Expected Behavior. I want to talk a little bit about who we are before I get into it. Expected Behavior is a company that we founded so that we could work at the last company we would ever work at. Like a lot of people in software, we were changing jobs every year or two, and we decided to just build a company where we wouldn't want to leave after a year or two. We started as a Rails consultancy and kind of evolved into a scalability consultancy, working with some big clients, people like Zynga, people like Salesforce, making sure that when somebody told them that Rails apps don't scale, we would call those people liars and make their Rails apps scale. Now we've transitioned into really being a full-time product company. We have some products that we kept identifying critical needs that the clients would have over and over. You always need these certain things, so we figured it's time to build some products to meet those needs, and that way we can help a lot more people write better software. But let's get into the talk. So in 1993, a little movie came out called Jurassic Park, and a little book came out called Code Complete. Code Complete was certainly not the first book to talk about unit testing, but for a lot of the industry, it introduced people to the idea of unit testing and really explained the benefits and the challenges and how to implement unit testing in an organization. So now, it's 2015, we have a new Jurassic Park movie, and you're here for application performance monitoring is the new unit testing. My name is Nathan Acuff. I work at a company called, I'm not gonna do the whole thing again, I promise. So, for people who don't remember, a lot of people probably weren't in the industry at the time. Unit testing was not an easy sell across the industry. It was hard to convince people to do unit testing. And the reason is real simple. It's expensive. You had to go in and convince managers and convince businesses and convince organizations, hey, we want you to spend your money on writing code that has nothing to do with your code actually running in production. That's all they heard. It's code that we can't actually use. It's code that doesn't make me any money. A lot of organizations said, we already have a solution for this problem. We hire the best developers, and that way they don't write any bugs. We have no regressions because we fire anybody who writes a regression. And those organizations are mostly out of business. The other thing is it makes your code cycles longer. So you have to write some code, then you have to write a test. Then if you're using compiled language, you have to compile it, you have to run the test. It adds more steps to that pipeline. And a lot of organizations were afraid that even though they were big lumbering waterfall organizations, it would make those cycles even longer. And I'm going to talk about a little bit why that wasn't true, but people were scared of that. So we got around the problem by convincing our organizations that all software looked like this. Imagine this function living in an invoice class or maybe in a user class within your application, and you're calling out to some external service, like a payment provider, to get invoice information. And so we told the world that software consists of little components that you can easily isolate and break down, and you can test each one in isolation, and then if they all work, your software will work, you won't have any regressions, and nobody has to get fired. The problem is that if all software actually looked like this, we might not need to write unit tests because there's just not a lot of surface area here. I don't know what can go wrong. Unless something breaks within that service, and then that's somebody else's fault, you can blame them, and hopefully your SLA contract is really, really good. The good news is that we won. Unit testing is on by default. There are so many frameworks, a lot of frameworks that have been talked about here. I know Node is really popular right now. Like I said, I'm a Rails guy. I've done a little bit of Node, but even .NET, even Java, even PHP, all the popular stacks have unit testing built in. It's on by default. It's always there. And thank God for that, because software has gotten incredibly complex. The availability of better tools and better frameworks means that we can do more and more interesting things. And the more complex something is, the more surface area you have a bigger problem. The better software gets, the harder it gets to write. The nice thing about unit tests is it makes the law of unintended consequences work for us. So you make a change over here, it causes a test to break over there. You had no idea that those two components had any coupling between them, but your unit tests, if you have comprehensive unit tests, can reveal like, oh yeah, secretly, these two pieces of code were related in a way that maybe you didn't understand before. The other great thing about tests, now that they're everywhere, is tests are a form of documentation. If you bring a new person onto the team, and he's wondering, oh, how does our invoice system work? Where do I get this information? How are these things compiled together? Go look at the unit test. The unit test should show you how invoices are built, how the code is expected to be executed. So let's say you've got some code that looks like this. It's basically the same thing as before, but we've added a little bit of caching. Just in case that external service gets slow, we don't want to make too many calls there. The fewer times you call out to somebody else, the less danger you're in. And a new developer comes in and looks at this code and says, aha, we've got a single equal sign after an if. That's obviously a mistake. Somebody meant double equals. I'll just add a double equal there and run the tests. And I've been in test suites that were totally reasonable, test suites that were written by very, very smart people who were paying attention to what they were doing, where it would not have failed the tests, because the tests were executing in exactly the right order that you would have a cached copy that would always be populated. And you could have mistakes like that creep into the code where now you couldn't pull any invoices that weren't already in your cache. I know I'm getting into a real specific thing here, but it is possible to have totally reasonable unit tests that can miss important things unless you are very, very careful in the way that you write them and the order that you execute them. Just as an aside, if you are currently executing your unit tests in a random order, good for you. Change the order every time. It's great. It will protect you from all kinds of bugs. So now I've spent, 6 minutes talking about unit testing, and you thought you were here to listen about application performance monitoring. So let's fix that problem. Nobody knows what you meant for your code to do unless you have some documentation or unless you have some testing. In the previous example, there's an equal, there's a double equal. You spend enough time looking at it, if you've seen the test, if you've seen the documentation, if you've had the discussions, you know what the intent of that code was. But if you're just looking at it for the first time without any context, it might be a bug. Libintent hasn't been invented yet. Once libintent does exist, I am going to retire because that will be incredible, but I think it's a ways in the future. So what kind of performance monitoring can we do to help protect us from some of those situations and to start to understand the way that our software works, not just in isolation and test, but actually in production? A lot of people right now are focusing on what I call either top-down or bottom-up monitoring. Top-down monitoring is you monitor all of your web endpoints, you monitor your traffic rates, you monitor your throughput, you monitor response times, and from there you can start to dig down into the application a little bit, but you start from just kind of monitoring the outer layer of your application. There are a lot of great tools for doing that. New Relic, it makes that super, super easy. They've started to get down and get into more interesting tools now, but that's kind of where they started. There's also bottom-up monitoring. So you monitor your servers, you monitor CPU and RAM, and how much disk space do we have left, and is the database happy? If you're using Amazon, you have CloudWatch. There are lots of other tools. If you're using Mongo, hopefully you're using MMS, or I think it's Mongo Cloud Manager now. But they're great tools for monitoring kind of from the bottom of your stack up. You should absolutely be using those. But I want to talk about something that's between those two things. I want to talk about monitoring that is really focused in the application layer, in the middle of your application, and how the application actually performs, not just is the code executing and is data being sent back to people that are requesting data. And I want to talk about how that relates to unit testing. So really, I'm talking about monitoring your business logic in production. In 2015, in the modern world of software development, you don't write software and call it 1.0 and then walk away and move on to the next project and you're done. Every piece of software is a journey. Every piece of software is a process. You write a feature and then you iterate, and then you iterate again, and then you get some feedback, and then you get rid of that feature, but then your customers complain, so you bring the feature back and then you iterate again. It's always a journey, it's always a process that you're going through. Because of that, monitoring your code in production for what it's actually doing is a wonderful way to understand how the application is actually behaving. You should be monitoring if something bad happened in your application layer. Absolutely hit it with some monitoring and see what's going on. If you write a new feature, you should write monitoring around the new feature. You can monitor feature uptake. You can monitor how it changes user behavior. If you write a new feature that's meant to reduce your support load, you can monitor, is it actually having the intended effect? And if you have a problem in production, and it has maybe multiple causes in the application, you can dig into your monitoring and find where those causes are. what's actually contributing to the problem? Do you have some of those unexpected correlations between components that I talked about before? So here is more or less the same code. Sorry, this is pretty Ruby, and I know it's supposed to be JavaScript now, but I am who I am. And I've hit this with some monitoring. So we are timing now, up in the top, the time that it takes to fetch invoices from the cache. This will tell us, first of all, are we getting invoices from the cache? Is the cache server behaving well? And do I have a network problem internal to my application? If you're in Amazon, sometimes the network gets weird for a few seconds and you need to be aware of it. I'm also monitoring the time that it takes for the service to return. So is the external service having a problem? Is my provider able to keep up with my traffic? Those sorts of questions. And then finally, I'm going to monitor the whole thing. So I can make sure that the number of times I call out to the service and the number of times I call out to the cache is equal to the total number of invoices that I'm trying to fetch. And this will expose, if I'm not great at capturing errors in this code, this can tell me times that maybe I'm failing to return invoice information. So you want to make sure that the sum of the parts does equal the whole, so you can see, yes, I am successfully doing something whenever somebody asks for an invoice. There's some code path that's executing. It is possible to get into monitoring overload. You can monitor too many things. If you start monitoring everything, pretty soon you spend all of your time digging through your data. It's just like with unit testing, where if your test suite is too large, if you're over-testing, sometimes it can be a problem. Test takes too long to run. You make one change, and instead of breaking 1, 2, maybe 3 tests like you should, you break 15 in different places across the test suite. It can be a problem. So I would say in general, though, it's better to have a little bit too much, like with unit tests, than not enough. But if you do find yourself getting into a problem, a great way to control how you're monitoring and to make sure that you're just monitoring the things that you really, really care about is to kind of think like a unit test. You know, software is a series of black boxes that you really, really are not supposed to open, but you're allowed to if you really have to, but you should pretend that you're not allowed to open them. And so anytime you have two components that are talking to each other, in the previous code example, we have our component that's actually fetching the invoices. Then we have a cache component that happens to call out to an external service, but we don't need to know about that. And then we have the service component that happens to call out to a very external service, but we don't need to know about that. We just need to monitor the interfaces between those components. Anytime we go get an invoice, we're crossing an interface between components. And just like we would test crossing that boundary, we need to monitor crossing that boundary and see what the timing is like and see how many calls are being made. Just as another little aside, for people that are doing application performance monitoring today, are you using it to monitor your service provider SLAs? Anybody? Wonderful. You guys are ahead of the game. I love you guys. Do that. You need to know if your external providers are actually doing what they're supposed to do. Your customers, when you don't meet their needs, get very angry at you. You should absolutely be getting angry at people that are not meeting your needs, because you're paying good money for software as a service. You need to monitor whether or not it's working. My organization, we're not perfect at that. We're about halfway there. We monitor a couple things, and it's the things that have let us down in the past that I won't name by name, but the more of those that you monitor, the more you can be aware of who is causing you problems that at the end of the day are not your fault, but you're still responsible for. But let's get back to monitoring and testing. So all the things that I've talked about monitoring, you might say, oh, well, we've got components and we've broken them down and we've defined the boundaries and we know where we can be testing, but I already have tests that break down my components and define the boundaries. Why do I need to monitor those things? Well, first of all, not a lot of people write performance unit tests. You can. I've certainly written some. We have a couple in our applications, but by and large, most components of your system, the only way that you really measure the performance of them under load is by measuring the performance of them under actual production load. At the end of the day, yes, I can test that the cache is working, the external service is working, but if something goes down in production due to a network failure or due to a server being overloaded, I don't want my customer to call me. I want to be able to call my customer. I don't know if you've ever reached out to a customer when your service is failing them, but it's not a great phone call, but it is way better than the reverse. Customers love to hear, oh, we're having a little bit of a problem right now. We're going to fix it. don't worry, all your data is going to be safe. They don't want to call you an hour after the fact and say, hey, we finally traced down the root cause of why our site is down, and it's you guys, and you're fired. So anytime you can be proactive in communicating issues that are affecting your customers with your customers, you're going to build a better relationship. The other thing is, it's a lot harder to write brittle monitoring than it is to write brittle unit tests. Everybody familiar with the concept of the Heisenberg test? The test that fails like 1 in 10 times when you run the test suite, but only under certain conditions, and not on my laptop, but on Joe's laptop. We've all had a Heisenberg test, and generally when that happens, you just restart the test suite and then it passes the second time, and great, let's ship it and get into production. Application performance monitoring, if you're monitoring that same piece of code in production, it won't be that brittle because the code will work or it won't work. And you can write a test to determine, is this actually failing 10% of the time in production and I've been ignoring it because my test suite passes if I run it again? Monitoring will always tell you exactly what's going on in production, not in an artificial test environment. And that can be really, really helpful, and it can actually help inform your test suite. So let's look at some monitoring. I know that the legend is completely impossible to read from back there. I will explain it. And these lines are cartoonishly huge so that they show up on the video, so enjoy. What I've got here is the light blue line is the response time of our service, where we're delivering information to a customer about their payment plan. And the dark blue line is the external service that's delivering invoice information to me from my payment provider. And you can see here, as the payment provider starts to get worse, we start to get worse. Not only that, we get worse at a faster rate than the external service. So it's not just linear. Something weird is happening here, where every time they take an extra 20 milliseconds, we take an extra 30. This is worth investigating, or at the very least being aware. We have a dependency here that we need to monitor closely, and if you see a graph that looks like this within your product, it's time to think about doing some caching and doing something to get those numbers back down. So what I want you to do is to be confident in every feature that you're shipping. That yes, this feature is working, it's not causing problems for people, it's having the intended outcome. A great thing that you can do when you're monitoring those things about your features is you can monitor feature usage versus resource consumption. So if you ship a new invoice feature, you can monitor like, hey, as uptake of this feature increases, is my cache server suddenly being overwhelmed? Which features are costing you the most in terms of supporting them? Not just in terms of machine resources, also in terms of resources like support. Did you ship a feature and it resulted in an explosion in open tickets within your support system? That's something to be aware of. That's a cost that you need to monitor and that you need to track. It also lets us observe those correlations that we weren't expecting between components. And if we can watch them, we can monitor them, we can fix them if we need to. We can do a little bit of refactoring and then see the outcome of that refactoring, not just in the normal red-green refactor loop in our test suite, but we kind of build the same loop into our application monitoring. And so we can see we did this, we fixed it, and yes, we shaved another 10 milliseconds off it, this is faster, and the code's a little bit more readable. Or we made the code a lot more readable, and it's costing us 5 milliseconds. At the end of the day, maybe we take the readable code sometimes. It's okay to get a little bit slower if it gives you some benefit within your organization. So here is very similar to the previous graph. I'm just tracking, so the dark blue line here, I'm tracking customer visits. The light blue line is usage of a new invoice feature. And the orange line is showing open support tickets. If you can build this kind of graph in your application monitoring, then you can see, hey, as uptake of this feature increases, we are saving money by not having as many open support tickets. Our customers are less frustrated. Our customers are more likely to renew and to sign up for more things. And our support staff can focus on things that are more interesting than, I can't find my invoice. How do I get my billing information? So doing this kind of monitoring where you're demonstrating how your features are affecting other parts of your organization is a wonderful, wonderful way to justify and to explain why you need to write those features that are really focused on solving your customers' problems. Because ultimately, we are terrified of our customers. If it wasn't for customers, I wouldn't care if my website went down. I could bring it up whenever I felt like it. Unfortunately, they really, really like to get the service that they're paying for. And I like to deliver it, so we need to be aware. If a problem is happening, we need to see that it's happening in real time. And then we need to be able to dig into that problem and see what the causes are and find those correlations that cause problems in applications. Accidental dependencies are such an incredible source of errors within an application. Two pieces that you didn't know were coupled together, and one fails, and it just sets off a cascade through the whole application where you didn't know, oh, hey, if our cache server goes down, all of our databases are going to crash, and it's going to take 6 hours to recover. It's those little dependencies, and that's not a little dependency, but there are little dependencies between components that when you can dig in and identify those in real time, you can save yourself a lot of headache and a lot of terrible phone calls. So in the last example, I talked about tracking the slowness of that invoice issue. You reach a certain point where you start timing out responses to your customers, and that's bad. You need to track that and be aware of where that slowness is coming from. If you have a system where you're using a queuing system like Rescue or like Rabbit or something like that, and you have many, many fast jobs and then a few slow jobs, it's easy to underestimate the impact of the slow jobs on your system. So you need a monitoring system that can show you kind of the total time taken by each kind of job. And you can see, oh yeah, we're doing 10,000 of these jobs and 100 of these jobs, but the 100 actually consume more worker time. And so if it's time to optimize, that's where we should be focusing our effort, not in this high frequency thing, but in whatever is actually taking up most of the time across our platform. The other thing I want you to consider is having temporary instrumentation within your application. So if you're deploying a new feature, if you're rolling out a new feature, if you are doing like a big remodel of your database, something like that, you can put in some monitoring, you can watch it for a couple of weeks to make sure, yes, this is working the way that I want it to be working, and then you rip that right back out because maybe you don't need it anymore. But it lets you be confident when you deploy something that it is behaving exactly the way that you intended. So let's look at more graphs. This is the billing service again, and you can see it's the same, the dark blue and the light blue are the same as they were with response time. Light blue is us, dark blue is our payment provider. But now I've added instrumentation for how many customers are actually using the feature. This also includes feature uptake on our end. And so yes, I can see that the payment provider is driving our website to be slower because they're slowing down as we request more invoices. But I can also see that we are what's driving them to be slower. We're delivering more traffic and they're not able to handle it. So yes, I'm dependent on them, but in a sense, they are dependent on us. We are driving their performance to be worse just as they're driving ours. Now, you're paying them good money to have good performance. So when you see a graph like this, it's time to pick up the phone and say, hey, you guys are slowing down a little bit. I'm sorry. Send them an email. I forgot it was 2015. Send them an email and say, hey guys, you're slowing down a little bit, and I have data. Here is a graph. As our requests pass 100, 150 a minute, you start to get dramatically slower. Can you support this load? Is there something else you're doing? Are you having network problems right now? If it sounds like they're going to take them a long time, it's time to think about implementing caching, switching providers, doing something on your end to bring this orange line down so that the blue lines stay down where you need them to be until you can come up with a better solution to the problem. So if you are monitoring those things, if you're aware that your users are out there, and if you are confident in all the features that you're shipping, you're in a good place. You're terrified and confident at the same time. That is the story of writing software. You've got some real-time feedback, and the important thing about your feedback is it's in a scope that exactly matches your concern. Your monitoring is kind of acting as your agent within the code in production, and it's telling you in real time, hey, this thing that you care about, this component that you care about, or this series of components that you care about, it's behaving the way that you wanted it to behave. You can understand that your feature uptake is whatever it is in production, and you can see it right now in real time. If you ship a feature and nobody uses it, then it's time to think about pulling the feature out, doing some marketing around the feature, refactoring the feature to make it more usable. But you have to know. You have to know how people are interacting with your application, or else you can't make their experience better. You will be resolving your features more quickly because you will find underlying causes and underlying correlations more quickly. And the best thing that happens when you're doing this kind of monitoring is that your operations staff and your engineering staff or your DevOps staff, if they're kind of merging into one, they they will have a shared understanding of the state of the application. Before somebody deploys, they will know, oh, this is the state of the application right now. We're having a little bit of a problem with this external service. I might need to wait a few minutes. Or this is the deploy that fixes the problem with the external service. I don't care if it's having a problem. Let's ship this right now and deal with the consequences later. So you can have a continuous shared understanding across your entire organization of the state of your application and how it's behaving. So how do we get started? Well, I mentioned before, a lot of people are doing two kinds of monitoring. Typically, organizations are doing both. You've got bottom-up monitoring, which is, are my servers about to crash? Do I have enough disk? Do I have enough RAM? Do I have enough CPU across my servers? Do I need to go get some more servers? It's very important to know that. Those are important questions to have the answers to. There's also top-down monitoring, which is how many customers do I have, and am I delivering results to them very, very quickly? Those problems are largely solved. There are a lot of great tools out there that do both of those things. Hopefully you're doing those things today. I'm really focused, like I said, on the application layer. It's application out. And the nice thing about having a very custom tool that lets you start in the application layer is you can grow up and you can grow down. We've used our tool, and you can use a number of these tools to monitor everything from, do I have enough disk space, up to, are all of my web endpoints delivering quickly? You can grow through the entire stack of the application. If you start from the middle, if you start from a tool that's really custom and that lets you put instrumentation in that acts as your agent within the code, within the scope that you want to address. So make sure that you're using a tool that lets you go anywhere within your stack, anywhere that you need to go, that lets you follow the data and monitor everything that you need to monitor. So where does this leave our tests? You've written a bunch of tests, and now I'm saying that it's time to, in some sense, start over and look at all of your code with a fresh pair of eyes and monitor it. But you have those tests, and we're going to use them. So a lot of your unit tests, a lot of what your unit tests can do for you once you start doing custom application monitoring is they tell you where are the interfaces between your components. Where are the interfaces between components that you really care about? You have a lot of information kind of hidden in your unit tests about where the interesting things are happening in your application. So for example, I mentioned that service.fetchInvoice call. That is also secretly monitoring your network connectivity. If you're using any kind of crazy proxying out to get out the internet, whatever your network setup is, that service will tell you what's going wrong just by monitoring that interface. Your unit tests, maybe you mock that call, maybe they have a test server that you used, but you have the ability there to monitor that. Say you have a little bit of code that is doing like encrypting a document, which I was talking about before we started here. If you have a little piece of code that's just doing that encryption, and in your test suite, it takes 2 milliseconds and it's done and you don't worry about it. Well, in production, if you're monitoring that, exactly the same thing that your unit test was doing, it will tell you, hey, are we running low on CPU on our worker boxes? We need to be aware of that. Your test suite can kind of guide you into where the interesting boundaries between components are and make your monitoring more valuable. My personal favorite in this, from this angle, is monitoring queue depth versus queue age, and I have a great graph about that later that I'm going to talk about. So I've said unit test a lot, and I haven't said integration test once. Integration tests exist, and they're wonderful, and they can tell us things about our monitoring too. So if you have a custom feature, you probably have written a custom integration test that simulates a user logging in and going through the steps and getting the result. You should go ahead and have some custom monitoring around the same thing. Anytime where there are multiple paths and you care about which path was taken, you need to have some monitoring to monitor who's going this way and who's going this way. In the case of the invoice, it's real obvious. You have 2 possible outcomes. You need to know how often it goes to one or the other. And if your traffic shifts entirely to one path and away from the other, then you need to know that and figure out why that happened. If you have special users who have special needs, if we have a product in production, we all have some enterprise client who wanted some crazy feature, and we said no, and they said, well, we'll give you a big bag of money with a green dollar sign on it. Well, okay, well, yeah, now we'll do it. We'll definitely do it. Our product has always done that. Just give us a minute to take it out of the box and flip the switches, and so we write that feature, and that's okay. But anytime you have a custom feature like that that isn't really core to the product or that behaves a little bit differently from the rest of the product, you have potential to have something go wrong and nobody notice, because most of your customers are not using that feature. It's a little one-off for somebody else. And so having some custom monitoring around that can tell you, hey, remember this thing that we did 6 months ago and then forgot about? We just broke it. Great thing to monitor. Really what I'm talking about when it comes to integration tests and the kind of monitoring you do related to them, it's whole life events that you need to be monitoring. So a user, you don't think about a particular piece of code or particular endpoint functioning. Think about a user is trying to accomplish something. A user is trying to perform some whole event, to get an invoice, to create a document, to find out a list of referrers to their website, whatever it is that you're delivering to them. And monitor and instrument, is that content being delivered, and how long does it take to deliver it, and is it working correctly? So we all have tests that we really, really wanted to write, and then we didn't because it's hard, and we had other things to do with our time. There are some tests that are really complex, maybe multiple components are involved, and it's too much mocking, it's too much stubbing, there are too many external service dependencies. It's like, oh, I would have had to spin up a separate server over here just while this test was running. And no, I get it. Some tests are really, really complex, and we decide not to write them. But those tests can be trivial to monitor. And so even if we don't have unit testing, we can still have production monitoring of that code that's extremely hard to test in isolation. And so it's not as good as having it as part of our test suite, but at least we can see if that code breaks. We can see what happened. We can see if it's slowing down. And we can relate it to the rest of our code and see if it has correlations to the rest of our code. It can also tell us if we start monitoring those things that are difficult to test, do we have a real problem with our code coverage? If your code coverage is 85%, you can slap some monitoring on that last 15%, and it might tell you, hey, of this 15%, there's a third of that you really need to be concerned about. And then there's 2/3 that maybe you can leave until later. So any place that's hard to test, you'll probably find that it's easy to monitor, and it can really save you some grief in the long run. So when do I know that it's time to start monitoring some code, whether it's tested or not? Simple rule of thumb that we have is if you have a question and you need to answer it and it takes longer than a minute or two, your monitoring is not good enough. Anytime that you have a question about how the code is behaving in production, you should be able to get an answer within a couple of minutes. Every time, if your monitoring is really doing what it needs to do. It's just wasted time. If you find yourself digging through server logs, there are some things that you can only find the answers to by digging through raw data, but for most questions, you really should be able to answer them more quickly. If you need to see the outcome of a change in your application, I don't know how many people went to the high availability talk yesterday, Braintree talk in the big room. He talked a lot about, there's chaos, there's external forces of evil out to destroy your application, and then also there's natural change within the application. So if something is changing within your application, you need to monitor those changes to make sure that it's changing for the better and not for the worse. And you can track that over time and see if what you're doing is good for the application or bad for the application. It's also important to have monitoring that tells you when something is happening within your application. If you have a deployment, if you have a database upgrade, you need to be able to see that associated with all of your data so that you know you're the one causing problems. For example, those gray boxes, they're impossible to see. Well, you can probably guess where they are. There are some gray boxes on two parts of this graph. What I'm showing here is the dark blue line is response time of just some example endpoint. The light blue line is 500 errors from that endpoint. And then the orange line is open support tickets. So what this can tell us, because we have custom monitoring that is monitoring the whole health of the application, I can see, okay, well, every time we deploy, yes, we're getting a little spike in response time because maybe our failover isn't as fast as it should be. And yeah, we get a couple 500 errors because maybe there are requests in flight. We haven't dealt with that yet, but customers know that it happens every once in a while. I mean, GitHub goes down for about 2 minutes a week, and we all keep using it. But the orange line there is telling me that every time there's a deploy, I get a bunch of customers that write an email and that open a support ticket. And that's money. That's money going right out the door. And that's time wasted because if your deploy process, if you spent some time refining your deploy process, you wouldn't have those open support tickets. It's possible to bring those numbers back down to 0. So whole life monitoring here, it can tell you where it is that you can spend your time within the application to get benefit for the whole organization. There is a danger once you've instrumented and once you've added monitoring to everything that you need to see, that you really can spend all your day looking at graphs. Graphs are really interesting. I love data. I love digging through data and just finding those correlations. But if you don't have all day to dig through data, I know that I don't, there are a couple ways that you can get kind of passive notification of the health of your application. A lot of people put up a TV monitor on the wall and have kind of the big board for the state of the application. That's a great way to do it. One thing that I would recommend if you're building a custom big board is make it color-coded. Make it so that you can glance out of the corner of your eye and see, aha, I see that there are some green numbers over there. I don't even need to know what the numbers are. The fact that they're green makes me feel good. Make sure that your monitoring system is delivering alerts. And it is okay to have soft alerts. And what do I mean by soft alerts? If you have a new feature and you want to see if uptake of that feature starts to go down, you can have an alert on that that sends you an email. Maybe that's not important enough to get you out of bed in the middle of the night, but it's nice to know that, hey, people have stopped using this feature. So soft alerts are a great way to keep an eye on something that you've put into production, but that maybe isn't critical to the functioning of the application. You should also have some hard alerts. We have one of our products, we've added some monitoring just around raw revenue. Every time a user takes an action, we've calculated about how much revenue that results in, and we have a graph that shows us revenue over time. And if that ever drops to 0 for an extended period, maybe somebody should get woken up at 3 a.m. to see why people are not able to interact with our site anymore. And it's because we're monitoring the result of the application. We're monitoring, are we successfully delivering what it is that the customer is asking for? And we can see, if that drops to 0, we're not doing our job anymore. It's important that your alerts get noisy on the right thing, that your alerts are really getting noisy when your application is failing. Not necessarily just when something interesting is happening, but when you are actually failing to deliver your product. Another great thing to alert on for soft alerts is if you have a feature that's deprecated. When you deprecate that feature, when you introduce whatever it is that's supposed to replace it, put some monitoring on the old feature that is just, hey, this feature is deprecated. And that way you can see, does this go down to 0 and does it stay there? If it starts to pop up, you can identify customers that are still using that feature, and then you can contact them individually. But if you don't know who's using that old feature, then you won't be able to get rid of it. So I mentioned before queue age versus queue depth. Here is a graph of queue age versus queue depth. The dark blue line is some very chatty job, some fast job that happens hundreds, thousands, even millions of times a minute. The light blue line is the depth of that queue. So as we can see here, the depth of that queue is all over the place. It never gets to 0. It also isn't growing that quickly. We probably have some monitoring on that, but it's going to be okay. The yellow line here is the depth of a slower job that maybe is actually more important, but it takes longer. We don't do as many of them, but we really care about the outcome of that job. And then the orange line is the age of things within that slower job queue. So if I'm looking at this graph and I'm just monitoring the depth of these queues, so I'm just looking at the light blue line and the yellow line, I don't think that I have a problem because those are both pretty low. And in fact, this light blue line is way higher than the yellow line. If I'm going to spend some time fixing this, the hammer that's sticking up waiting to get beaten back down is the light blue line. But once I'm monitoring queue age, now I can see, actually this thing that's way down at the bottom that looks like it's completely healthy, it is completely falling over. It's going to fail, it's getting too slow, and pretty soon people are going to start asking, where's my data? Whatever the result of the job, why don't I have that result right now? So this is just a pet peeve of mine. When you're monitoring your queues, yes, depth is important. Monitor memory on your queuing servers and make sure they're not about to fall over, but age is far and away more important. You need to know how quickly those jobs are being processed. It's much more important than knowing how many of those jobs are happening at any given time. If you're going to alert on something, alert on the age. So this sounds great. We can alert on whatever we want. We can monitor any part of the application. How do we get the credit card so that we can actually get some application monitoring? The good news is there are open source tools out there, StatsD, Graphite. Those are the only ones I have on top of my head right now, but there are great tools out there for building graphs, doing this monitoring. You don't have to spend any money. But you still have to justify spending some time on this within your organization, and that can be tough. So just like with unit testing, where we had to explain how in the long run this was going to benefit us, there are some organizational benefits that you get from custom monitoring. You can answer mission-critical questions about the state and the behavior of your application in real time, right now, in a couple of minutes instead of a couple of hours. You can also move the information that you need to answer those questions from their individual silos into a shared space. Certainly, most people probably worked in an organization where when a certain thing happened in production, you knew that you had to go talk to this one person because they were the keeper of secrets for that application. And they could tell you immediately, if you could only get their attention, they would tell you exactly what was going wrong, but they had all the information. If you have monitoring that's telling you what's going on across your application, you can move data out of that person's head and into a public space where people can see it. And then if it's really important, you can put it on a big board, you can write some alerts for it, and it becomes shared information. You're going to be able to become proactive when it comes time to contact your customers. You're going to know which customers are using which features. You're going to know which customers are your heaviest users of maybe features that take more resources to support. You're going to know which customers are using the application in exactly the way that you intended. Or maybe you find some customers that are getting some benefit that you didn't expect from your service, and it's a new opportunity for you to market that benefit. Knowing customer behavior is a wonderful, wonderful thing. And seeing it in production is really just the only way to get the information you need. The other thing that you can do is I talked a little bit about unit testing as a form of documentation, so you can express to new developers the intent of the author of the code. Monitoring is also a form of documentation for new developers. You can show people immediately, hey, these are the things that we care about. Our platform is intended to deliver these 9 features, and here's a graph showing all 9 of them and how quickly we deliver them and how frequently. These are the pieces we care about, and here's the monitoring for those features. Here's where the rubber meets the road on those features, and code is actually being executed and results are actually being delivered. So new people can see right away what's actually important to the organization, and they can see how the things that are important are behaving in real time in production. I want to talk about one more graph. I've built this graph a number of times, and I deserve all of the shame and guilt that a person can bear for building a graph. This is the danger graph. It's marked as temporary, but it has no expiration date. And that line is tracking some unknown horror. And you really want for this to stay 0, but all of a sudden it's spiking. I don't know why it's spiking. I don't know what it's monitoring, or if this is going to take the application down. I don't know if this has anything to do with any customer. Somebody made some monitoring that is a bad thing happened. And now people who find this later, maybe that person's left the organization, maybe they called in sick that day, maybe they're on vacation, I don't know. We just know that something they cared about a lot is happening and it's bad. So when you are writing your monitoring, consider that your monitoring is a form of documentation. And yes, you're collecting some data, but you need to make sure that the person who looks at that data has the ability to convert that data to information. I recommend that as you implement monitoring for things that aren't obvious, start to build a monitoring book for your organization where you can say, okay, things that are tagged like this are monitoring this piece of the application. Things that have this particular naming pattern are over here. Build a list of what those things mean so that people can find new monitoring, people can see what's going on, and you don't end up panicking because some graph that somebody built suddenly spiked and no one knows why. So I'm going to wrap up. If you want to start thinking of questions, that's great, but I'm going to just real quickly go over the whole thing again. Don't worry, real quickly. I talked about how unit testing adds time, adds safety, and in the long run saves your organization money. It also saves your organization embarrassment, which is a form of currency in the software world. And I talked about how application-focused monitoring can do all of those same things for your organization with your code running in production. I just want to encourage everybody, when you're doing this monitoring, follow the data. If you don't know the answer to a question, use clever monitoring to find the answer to the question, know what the answer to the question is, and follow that data wherever it leads you to whatever the solution to your problem is. Take those results, feed them back into your engineering process. Your engineers should be able to see at any given time what is the state of every piece of the application so that they know what they're working on. Is it delivering a benefit? What is the benefit? Do I need to focus more on clarity or do I need to focus more on speed? Do I need to ship this feature right now or can I take the time to do a more thorough refactoring? Your engineers need to have this data available to them and they need to see that data for themselves in production. I also want everybody, just across your whole organization, share those results. Know if your features are creating more open tickets, know all of those little pieces, anything you can monitor, share results across the entire organization. Build custom dashboards for your marketing people. Let them see the behavior of the application. Let them see the uptake of features that they're marketing so that they can get feedback on their job from your application in production in real time. It's a great thing. Once you're sharing that information across your whole organization, you all work together better and you get a better result for everyone. I'll be up here for a couple minutes if you have more questions you want to ask. Thanks everyone for coming.